Cassini's 7-year journey to Saturn began in 1997.
And liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
And from its arrival in 2004, the orbiter, with its European Huygens lander, has transformed our understanding of this gas giant planet, its distinctive rings and multiple moons. Huygens landed on Saturn's largest moon, Titan, in 2005, and together with observations from Cassini, found methane clouds and lakes, as well as canyons flooded with hydrocarbons. Cassini also unveiled closer images of other moons, such as Prometheus, the sponge-looking Hyperion, and even one moon, Mimas, that resembled the Death Star from science fiction's Star Wars, while Enceladus is covered in icy ridges with active water jets on its south pole.
My favourite moon is Enceladus, and the reason I'm partial to Enceladus is it's the moon that my team discovered a water vapour plume at. But not only is there liquid water underneath the surface, but there's organic material, there's a heat source. And you know, when people get excited about the potential for life elsewhere in the solar system, there are 4 things that you need. You need a heat source, you need liquid water, you need organic material, and you need those 3 things to be stable over some period of time so that life could potentially form.
Enceladus has 3 of the 4 conditions for life. The only thing still under debate is their stability over time. And this exciting finding helped define Cassini's priorities for how it would end its successful mission after years of extensions.
After 20 years of operation, the spacecraft is running out of fuel, and it becomes increasingly difficult to navigate it through the system. And what you want to avoid is to crash on one of the icy moons like Enceladus, where habitability and a huge astrobiological potential has been discovered.
This potential life could be locked inside the liquid ocean beneath Enceladus's icy crust, where the hydrothermal heat sources are also located, in the same way that life has been found deep in Earth's dark ocean depths near hydrothermal vents. To make the most of its last few months, Cassini has been performing some daring manoeuvres, diving through the gap between Saturn's upper atmosphere and the icy particles that make up its innermost ring, for a final series of 22 orbits. It has allowed closer glimpses of Saturn's hurricanes, some with winds reaching 500 kilometers per hour, and the hexagonal spinning storm at its north pole. This is as wide as 2 Earths, and surprised everyone when recent images showed that over the years it had changed colours from blue to gold. In a few days, however, Cassini's adventures must come to an end.
During the final orbit on September 15, we are going to dive at 30 km per second through the upper layer of the atmosphere. The spacecraft will be able to maintain for 1 minute approximately the pointing to Earth with the high-gain antenna. And at the end, the drag force of the gas will destabilize the spacecraft so much that we will lose the link to Earth, and this is then the end of mission before the spacecraft burns in the atmosphere.
In its final moments, Cassini will become an atmospheric probe, sending back scientific data from Saturn, including information about its magnetic field, until its demise. When Earth receives this new data, the spacecraft will no longer exist. But the discoveries will continue. So far, the Cassini-Huygens mission has produced around 2,500 scientific papers, with 1 in 3 led by a European scientist. And so the legacy from this successful collaboration between the American and European space agencies will continue to open up Saturn's secrets for decades to come.